So our next session is looking at some of the practical solutions of what we're looking at. And on the Zoom, we have Michael Ayres, Brian Clavin, and Alexandra Hammond, who will be running through some of the issues. So what we wanted to try and look at here is transport, EV, the fundamentals of what the impact is going to be, and some of the problems we're going to be facing and some of the solutions. We're also looking at so EV and storage seem to be the issues at the moment. So Brian's going to come in and talk to us about storage and some of the ways forward on that. And then we have Alexandra. Now, Alexandra has been on the board of the EMA and has worked in the public sector for quite some time, and then the private sector. Alexandra will be looking at frameworks because of how you actually find companies and the technology and the that can actually provide the solutions and be integrated through the project through frameworks. So I'm going to kick off with Michael. I'll do a quick introduction. Michael, years and years ago, used to be my researcher, and we pushed through we almost pushed through a private members bill. Michael wrote single-handedly in Parliament, and we would have actually pushed it through Parliament, except at the time the government turned around and stole every single measure and stuck it in regulation, apart from one. So that worked out rather well. But we did an enormous amount there, and it all got nicked. But it got made into law. So, Michael, you're an expert on EV. Do you want to give some background and run through some thoughts?
Yeah, absolutely. But morning, everyone. My name's Michael Ayres. Rupert's asked me to say a little bit about transport. The company I work for is Flexible Power Systems, and what we do is we're basically a technology company in the logistics sector. Do I have control of the slide deck, or do I have to ask for the next slide? Okay, so the short answer is absolutely we have to tackle transport. It's about a third of UK emissions, and 90% of that comes from the road sector. I guess it will be no surprise to anyone on this call that cars dominate that picture, representing about 80% of the fleet. And they're also pretty important from an emissions perspective. But when we look at businesses, that whilst there's a relatively small absolute number of vans, buses and HGVs compared to the cars, they have a really disproportionate impact because of their usage patterns, and also that, frankly, they're just larger vehicles. So that HGVs and vans and buses are absolutely on the decarbonisation agenda for net zero. Can I have the next slide, please? Great. In terms of what's being done at the moment on the legislative side, I can see that already that people have been talking about the 2030 ban on internal combustion engine vehicles. In the HGV segment at the moment, there's a voluntary commitment to reduce emissions by 15% by 2025. I think the consensus is that isn't going to be enough, so that there's a consultation planned on how to get rid of diesel from HGVs coming over the next couple of years. I'd expect to see that. And obviously the transport emissions are being reported in schemes like ESOS and net zero commitments. In terms of how business is responding, that there's very large quantities of EV investment on the table from a number of different businesses. There's also coalitions forming to try and push the government along to more ambitious targets. And I guess that the reason for that is, though, that adopting EVs can be difficult and can be challenging, but actually if there's clarity about the need to do it, then people can start to plan and move forwards. In the HGV segment, things are a little bit less mature, though that there are some isolated companies that are making quite large commitments to biogas and starting to look at purchase orders for quite large volumes of hydrogen fuel cell trucks and also electric trucks. And obviously the transport is included in their net zero commitments. So in terms of what's happening in the passenger car and van segment, that it's worth saying that the EV business case is actually there already for a number of different vehicle types. One of the things which is just being talked about really is the fact that local electrical distribution infrastructure challenges are likely to become quite significant, particularly in places where we get a lot of vehicles sort of congregating together. And the other thing to say about decarbonising passenger cars and vans is that modal shift is always an option. So in many of the UK cities, that parcel delivery companies in particular are actually running portering and e-cargo bike schemes where the drop density is high enough. So that's something which is always worth considering. In terms of the HGV segment, things are a lot less mature. Basically, the fundamental challenge is moving 44-ton trailers, like you can see in that picture, hundreds of miles, is massively energy intensive. And so using hydrogen or batteries to do that is really challenging. The other thing to say about it is that every option that I can see on the table will probably need a government investment in centralized infrastructure to make it work. So that might be the sort of hydrogen distribution center that's be targeted sort of solely at HGVs, or it might be sort of some kind of electric road system to make an electric solution work, that no one will buy the trucks unless that they've got the means of recharging or refilling them. And equally, no one will build the infrastructure. So someone has to break that kind of chicken and egg cycle. The other option you've always got is to shift onto rail, but that can be hard to fit within people's logistics operations. The chart on the right gives you a kind of picture of the sort of relative energy demands that we're talking about. The red bar chart tells you how much electricity was supplied in the UK last year, and that the blue side of the chart gives you a picture of how much energy is used for HGVs today. Biomethane probably can only be a niche solution in this segment because we simply don't have enough of it. Even the sort of supply potential talked about by organisations like ADVA doesn't get you up to the full HGV demand, and that's assuming you devote none of it to heat. EVs would require a bit less energy because the powertrain's more efficient, but it's still substantial in terms of the overall commitment level. And hydrogen, if we use green hydrogen produced from renewables with compression steps and electrolysis, that will actually increase the energy requirement, but it's still sort of within the bounds of overall electricity supply if a massive amount of energy. The other thing I wanted to share was that, why should we think about doing things differently? Because that sometimes when we talk to companies about sort of their EV plans, for example, that the start point is, well, let's just do something where we replace all the diesel vehicles and do exactly the same thing with EVs. And that probably isn't going to work at national scale for several reasons. So that one of them is electricity generation. So if we make no improvements in terms of the efficiency with which we're using vehicles by sort of, trying to encourage people to use public transport or looking at sort of better load consolidation and things like HGVs, we could end up needing 240 terawatt hours of electricity to support the transport demand, which is going to be a big ask given where electricity demand is today. The other one is transmission capacity. The peak demand on the UK system's fallen a bit in recent years, around about 60 gigawatts. There was a 2017 National Grid study that suggested that if we don't manage EV charging, we could end up with 18 gigawatts of extra peak load from just charging the cars, which would be a very challenging and expensive thing to manage. And then finally, that there's a lot of equipment that we need to address. That so far that we've got about 300,000 plug-in vehicles of all types in our transport system today, and there's about 39 million vehicles in the fleet. So that if we keep the same number of vehicles, so we don't make any kind of progress in terms of servitization of access to vehicles, getting people onto public transport, perhaps going for sort of larger, more efficient vehicles, then there's a very large number of charging points and vehicles that need to be converted. So I think that's everything I wanted to share, and I'm looking forward to questions in the panel session.
I just want to throw some questions at you. So it's quite funny. UK ban. We just had a poll. The UK PM to ban sale of new petrol cars. Is it too soon, 33%, or is it not enough, 67%? I mean, there is a massive willingness for people out there to move to electric vehicles. Obviously, as an electric vehicle owner myself, I would suggest to people they go down that route. It is fantastic. But what is your view on whether it's a great thing to say but impractical, or whether it is practical?
I think it is practical, and I think there's a necessity for a target like that. So one of the pieces of feedback we get from our work with companies who are predominantly looking at sort of van fleet electrification is that the OEMs are not supplying enough electric vehicles of the models which are available to the marketplace, and that there's insufficient model choice. So it's a particular challenge in the commercial vehicle segment, so that there's a lot of enthusiasm from companies that we talk to for the ban, because they feel it will force action from the commercial vehicle industry. I think in terms of the passenger car segment, that there's already kind of a changes afoot, that I think pretty much every OEM, driven by the Tesla effect, now has EV offerings or plans to offer EVs in every single one of their model ranges. And I guess that sort of model availability is kind of the first step to it, and then the cost is the other part to it. Whilst I recognise that there's greater costs in some segments of paying for electric vehicles at the moment in terms of the purchase price, that actually that in a lot of situations that they pay back over their lifetime, and so have an attractive business case. And so that the challenge that you've got is really how to square these sort of higher purchase costs with the lower operating costs. And I think there's really kind of a role for finance in those kind of situations.
So if you're going out to a company and advising them, what are the top sort of three things that companies should look for in when they're thinking of making a transition?
So that one of the things that companies we talk to are very interested in is sort of correct model choice, so that there's quite a lot of variability in terms of the capability of the electric vehicles you can select still. And so there's a real trade-off between spend on the vehicles and sort of effectively how far you can drive them, what the payloads are. And then the other thing which is really rising up the agenda is connection costs, so that a lot of transport programs are not necessarily connected to sort of energy managers. So that I've spoken to retailers where that large commitments to sort of EV adoption have been made by transport, but without actually talking to the energy managers or estates teams. And so that's then driving two concerns really. One is to do with distribution network connections for the sites, so increasing power demand basically. And then the other thing that people are interested in is what the impact will be on their overall electricity spend. Because for some companies that the fleets are large enough to make a difference to your sort of hedging strategies and things like that. And so that needs to be taken into account.
Yeah, so we've had a question from John Moore. This is assuming that electricity prices stay where they are. I suppose if there's a massive amount of demand for electricity through transport and heat, which we haven't really talked about, but is the one, is the big elephant in the room. We use 2/3 more energy on heat than we do on electricity. So I suppose if we're looking at heat, we're looking at transport, and we're looking at present electricity use, is that going to send costs up, and how would that affect the model?
Yeah. So I guess that the sort of the start of the answer to that is it's complicated. And as an economist, that I'd say also that it depends really. So that I think that the dynamic that we might see is not necessarily sort of electricity prices increasing all of the time. I think that what we're likely to see in future is greater volatility in electricity prices, and so that electricity will become more expensive at certain times of day, and actually that we're seeing a trend towards sort of lower priced electricity in sort of super off-peak time periods. And so really making that transition work with even just the EVs actually, and everything else that we're trying to do, requires technologies like smart charging in order for it to work, so that we don't sort of end up sort of all consuming in the peak times, consuming expensive electricity, maximizing our infrastructure spend.
So I suppose this is going to come on to storage, and it's also going to come on to the funding envelope, and what should be included in any framework document coming down the line. So we'll be covering those later. But I suppose one of the problems we've come across with some of our energy managers is they've decided to electrify, they've decided to stick a load of charge points, but they haven't got the transformers.
Yeah, absolutely. Network connections are an issue, and we've seen examples where the connection costs have sort of added unexpected tens, or even in the case of the bus industry, hundreds of thousands of pounds to installation cost. So that we try and tackle that with our clients by sort of building up a picture of quite detailed charging profiles at the sites, and then using that to work out what you can do in terms of optimizing with smart charging, maybe installing storage, time connections and things like that. So that I think that those connection challenges are manageable, but it requires a good deal of planning and simulation beforehand.
Do you think the DNOs, the district network operators, are up to the job? I know there's a new metering system, P375, coming down, which will look at time of use charging.
Yeah.
Is it a smart network we're looking for?
I think it is a smart network. I think that many of the DNOs that we've engaged with are alive to the challenge of EV deployment and what that means for the distribution network, and that you constantly get the message from them that they don't want to be seen as blockers of EV deployment, and so that there's a lot of initiatives going on to try and ensure that there's sufficient capacity available. And I guess what you're referring to, Rupert, is visibility of what's happening on the lower voltage parts of the network, because they're not instrumented in the same way. So yeah, the changes to the metering code and regulations, like sort of P375, as you mentioned, give an opportunity to DNOs to have a bit of visibility of what's going on behind the boundary point, rather than just what you can see for the overall site level itself. But there's absolutely more generally a case for much more sharing of data between sort of users, distribution network operators and flexibility providers if we want the system as a whole to work.
So I suppose one of the things we've always had is, everybody can have a car outside. It's got 300 miles worth of energy in the tank. We can do what we like with it. Would you say that going forward, we might have a different model where that's not necessarily the case, where we can't use transport in the same way we've used it before?
I guess that the engineer in me says, well, wouldn't that be a wonderful solution? But the sort of the human in me realizes that might be quite hard to enforce in practice. I think that, I guess there's a couple of aspects to that. There is going to be a challenge for the car segment in terms of supporting those very long distance journeys and what we do about sort of ultra fast charging to make it feasible to drive from sort of one end of the country together on the small number of occasions that most people need to do it in a year. I think it is also fair to say that perhaps the demand for some of that sort of flexibility is beginning to go away, because that COVID times accepted that there's been a kind of reduction in interest in driving from sort of younger generations, and a sort of growth in usage of public transport from them, because for sort of various reasons that are often put forward, like, for example, the ability to be able to use a smartphone whilst on public transport, but not whilst driving. So I think that some of the answers in modal shift, some of the answer is in terms of having the charging available for the people who need to do those trips.
Rosemary Horry has come back saying electric vehicles are very expensive. Is that likely to change, or?
Well, I think it's fair to say that prices for electric vehicles have been coming down every single year as the price of lithium-ion battery technology has fallen. That the falls have been sort of really quite astounding. I think it is fair to say that the purchase price of an electric vehicle today is significantly higher than a sort of diesel or petrol vehicle. But I think that we'll see a lot of progress in that over the next 5 years as the production volumes increase.
And I suppose before we go on to Brian, I suppose one of the questions is, now that this target is being introduced, production is going to shift over, and most people are going to have an electric model for every type of car they've got. Yeah,
and that's absolutely happening. So that I don't think that the 2030 target has come as a surprise to the automotive industry, and so that there's been a certain amount of preparation from this, and so that most of the major manufacturers have announced that in every single sort of vehicle class that they offer, that there will be electric options already before this announcement. And so I think it's sort of a question of sort of everyone having a solid target to aim at now.
Excellent. So thanks very much for that. We had some questions about hydrogen. I'll just finish off. Do you see hydrogen heavy goods vehicles being a reality in 9-10 years time?
Well, I suppose that sort of from one perspective, I can see challenges around the overall energy efficiency of the chain, and can remember that hydrogen fuel cell vehicles have always been about a decade away for at least the last 50 years. So I kind of appreciate that there's a number of challenges of hydrogen and full storms. I would say though that most of the major truck OEMs now have large scale fuel cell development programs. So it's not the situation where it was before, where you might have a niche technology developer deciding that they were going to enter the truck industry. It's sort of large scale players like, you know, sort of Mercedes and Toyota who are entering this market now with hydrogen offers. So I think that there will be products available, and I think that there's an interesting tussle on the horizon between the sort of industry interests who want hydrogen to succeed because of it fit with sort of maybe existing hydrocarbon or industrial gas distribution infrastructure, and proponents of electric solutions. And so that I'd expect we'll see some sort of large scale trials over the next 5 years or so, trying to sort of get to the bottom of which one we can do. Because I think it probably isn't the case that we can afford to deploy all the infrastructure to support both hydrogen and electric trucks at scale.
Excellent. So thanks very much for that, Michael. We'll take questions a little bit later. Moving on, Brian, you're looking very nautical today. Oh, you're on mute.
I'm down on the coast of South Devon, so I suppose I probably do look a little nautical.
Yeah, very jealous. So, Brian, do you want to give so you're an expert on the deployment of storage. Do you want to give some background and some thoughts on that?
Sure. I actually came out of the data center industry for the last 20 years. I've been in and around the data center industry in a material way, and left employment for data center employer a few years ago and joined a group called Total Data Center Solutions, which is a consultancy for data center industry and beyond that specializes in disruptive technologies. And about 2 years ago, we were approached by an organization who came to us and said that they have a business solution around battery energy storage to enable organizations to acquire battery energy storage at a zero cost and to create savings on the basis of that. The long story short is we decided to go with them, and the entire business has moved at an extraordinarily rapid rate. Battery energy in itself in the UK, and in fact the entire world, is becoming increasingly important in a big picture sense because of the rise of renewables. And the renewables are wonderful ways to generate electricity, but they're not always reliable. And that intermittency, when the sun shines and the wind's blowing, they're producing tons of electricity. When it's dark and the wind's calm, they're producing nothing. And effectively, that intermittency wreaks havoc on the grid in terms of keeping it stable. So batteries are an extraordinarily important element of both individual powertrains, but grid scale powertrains too, because they can absorb the excess energy when they're when the wind is blowing, and they can deliver energy into the system when the intermittency of renewables it shows its face. So batteries themselves aren't green. Particularly the most pervasive technology now is lithium ion. The sourcing of lithium in conflict zones has its own problems and a bit of a dark side to it. But what batteries can do when connected to the grid or an individual site, they can really work some wonderful magic. And the battery industry itself is moving very, very quickly in terms of new chemistries, new anodes, new cathodes. So, and each of these developments are becoming, or are going to allow batteries themselves to be quite green, certainly more so than they are as lithium-ion batteries. So back to a little bit of a story. When we were approached by this group saying that they had come out of the big solar business, they had built 68 big solar farms here in the UK, and they had packaged it up financially and sold it as a solar bond with an 8.9% yield to insurance companies and to pension funds. They had watched, they're bright guys and they're a fantastic group. What they had watched the fall in the price of lithium-ion batteries while they were doing their solar farm, and decided to enter the battery energy storage business, utilizing a similar model to what they did with their solar farms, where they would go to a farmer and say, we will build a 10, 15, 20 megawatt solar farm. We will ask for a lease at a nominal rate for it to be put on your site, but we will share the income stream with you in order to be able, for them to be able to acquire the land they needed, but not have to pay an extortionate premium. They moved into the battery business about 3.5 years ago, and the offering that they've put forward to big users of electricity, which is in our world, a big user is somewhere, a minimum somewhere between 100 and 200,000 pounds a year. They will design, build, finance, own, and operate the battery alongside that user of electricity, use the battery in clever ways. Oh, thank you, Chris. That's really kind. I was going to get to that. In using the battery in clever ways, the simplest form being charging it up at night when it's inexpensive and putting it and discharging it during peak hours, but also delivering the grid services that are referred to help the national grid and the local operators keep their grids in balance. You get paid to deliver services to the grids in terms of inputting that power as needed. And effectively, they will, as I said, design, build, own, operate, and finance these battery energy storage systems, which will, this is a great slide. If you look at it, I'm talking about batteries for the moment, but I'll expand up from there. They will then do they will take the batteries, run them through their lives for a 10-year contract, and they will share 50-50 the savings that the batteries can create across that contract period. Normally, we can save, overall on an energy cost, we can save about 20%. So an organization can gain a 10% or circa 10% savings on their energy bills at zero capex and zero opex. Chris, could you put that last slide up again, just for a sec? Thank you. So for those of you who can see that, hopefully, if you can imagine you as an energy manager are currently looking after the lower part of that slide. So you've got your facility, you've got your distribution units, you've got your meter that you pay every month, and you're connected to the grid. Energy optimization will come in and install a properly sized and operated battery energy storage system and save circa 10% a year. But they've also widened their offering to on-site solar, both in terms of rooftop solar and canopy solar over car parks. They will install and operate EV charge points, and they will install and operate CHP, both new installations and replacements of existing CHP that might be aging. And the CHP that we're currently deploying currently runs on natural gas, but the systems that we're using can, with a very small modifications, can run on part hydrogen, part natural gas, and ultimately they can run on pure hydrogen. So there was a number of comments in the previous session about one of the big stumbling blocks and barriers, as Sarah called them, is financing, and budgets. So effectively, the business choice up to this point in time was either a CapEx solution or an OpEx solution. Using energy optimization's model, you can now acquire each of those technologies in the top half of the slide at zero CapEx, zero OpEx, and create savings along the way of roughly 10% a year across a 10 or 15-year term. So I think that's really important, both in terms of being able to help organizations move towards net zero, and as importantly, save money on the way. So we're really excited about this. We have plants out and live now. We have a pipeline of 110 megawatts of projects, including on-site solar, near-site solar, CHP, etc. And this is available today to energy managers across the UK. So I think that's my first message that I wanted to share. The second one is related to the IT computing business, and who are some of the biggest users of electricity in the United States, in the UK and around the world, including one facility in the east of London whose annual power bill is £28 million. Thank you, Chris, for putting that up. So to date, the way data centers are built is they are incredibly sophisticated big boxes with lots of electricity and power going in there, the proper way to distribute it, huge air conditioning and air handling systems, and they take up lots and lots of space. The technology that you see on the slide there is a rather innovative. It's been around since about 2008, but it is effectively in the marketplace a new and incredibly green and efficient technology that allows one to completely change the way that servers, storage, and networking kit is looked after. And as counterintuitive as it sounds, this is called immersion cooling, because what one actually does is to take the servers and storage, and hopefully you can see that the slide's a little bit dark at my side, but what you see there is a data center in Serbia, which is the world's first zero carbon data center. And the boxes on either side of the aisle are actually 8 immersion cooling tanks. You can see, hopefully, you can see a number of the top lids open on various of the immersion cooling tanks. So back to the point, you can now take these servers, which create enormous amounts of heat with the density of chip technologies. You can immerse them in which is effectively a synthetic mineral oil, close the top, the energy and heat from the servers as they're operating goes into that mineral oil. And Chris, if you could just jump to the next slide. You can see that there's a single tank with its lid open. The storage and servers would be inside of that. The mineral oil exits to the right. You can see the red pipe into a heat exchanger, which then transfers that heat from the mineral oil into a water tank, with a heat exchanger water tank, where it's taken outside and put through a cooling tower and returned as cool water, which then becomes cool, which cools the oil and puts it back in. The net of it is you can save about 90% of the cost of cooling electricity using this technology, and you can save about 30 to 40% of your overall cost of compute. And the reason I wanted to show this to you is because very few people in the United Kingdom even know this exists. But, and Chris, if you could jump to the next slide. If, sorry, keep going, I think two more, keep one more. Okay, if you're an energy manager, at some point you're going to get pulled into discussions with the computing teams, and they are likely to be out of power, out of space. They're still facing increased power cost. You've got these incredibly high density chips that are operating now and making life in a normal data center incredibly difficult. Capital is always a problem. Location constraints, etc. You can actually deploy these immersion coolings in any room that has access to an outside wall and has sufficient power to run the machine. And they are incredibly green and will materially move you towards your net zero goals in the compute side of things. So that's the two things that I wanted to share, and you understand that they are out there and available. I can provide you with lots more details for any of you who are interested in either of those technologies. And the last thing I wanted to share, and this is just purely a resource for you to be able to get.
Chris, Brian, just on that, Chris Mayhew has asked, you could then use the heat for for district heating or ground source heat.
Absolutely. Well, district heating and or putting it into greenhouses or industrial processes, etc. Because the exit temperature of the mineral oil as it leaves the tank is circa 45 to 50 degrees. The energy density, once it's put into the heat exchanger, is completely suitable for district heating schemes, either residential or commercial, or for it to be used for either industrial or agricultural purposes. That's another ancillary but meaningful benefit of immersion cooling. Correct.
Sorry, I stopped you in mid-flow.
No, that's fine. I'm sorry, a little soliloquy. I promise I'll stop really soon. To all of you who are listening, please listen to this one. This is a free resource with a group called, curious name, Thunder Said Energy. They are a consultancy around the energy business. They're based in the States, but certainly one of the principals is a guy named Rob West, was educated here in the UK. They have an incredible resource around the reports that they create on every element of the energy business you could possibly imagine. The website is free to sign up to. It is, they publish once or twice a week, basically an executive summary of the reports that they're creating, but they're free to read. They're incredibly detailed, dense, and well thought out in a real quant manner. They are real business people. And if that slide there, if you can imagine that each of those vertical bars is one or more segment of the energy business, each of those bars they've done reports or multiple reports on. As I said, it's free to sign up to. I'm not on their payroll. I stumbled on it about 1.5 years ago, and it has been the most incredibly valuable resource on an incredible range of energy systems. And I mean, they go through gray hydrogen, blue hydrogen, green hydrogen. They go through carbon capture. In fact, if you just stop there, one of the reports, and these are not sandals and long hair and flower guys, these are real business people. But most surprisingly, when you get a chance and you do sign up, do look at the article called Planting a Seed for Forests Disruption. They are actually showing that the least cost carbon capture is planting trees. And as counterintuitive as that sounds, the cost per ton is lower than any other carbon capture element, and it benefits the planet in multiple ways. So all I'll finish up to say, please call it up on your computer, sign up to it, and enjoy it. You can buy the reports if something's particularly important to you, but they're modestly priced. They're like $300 or $400 US, but it is just an incredible resource for each of you. And I hope if you get nothing else out of my little soliloquy, you can get energy. You can actually have battery energy storage at zero cost. You can do immersion cooling and change the way your company computes and delivers compute. And Thunderset Energy will be your guide to many, many things.
Thank you, Brian. I suppose we've got time for just a couple of points. How big does an energy manager's energy supply have to be before you think sticking large-scale batteries or medium-sized batteries into the system works?
There's two tiers. For an acronym for battery energy storage system is a BESS. So if it's a pure BESS deployment, the host site should be having an annual power bill, electricity bill, of about £200,000. If a BESS plus each of the other items that I showed you on that earlier slide, so CHP, on-site solar, near-site solar, EV charge points, etc. That's called BESS Plus, which is something that I came up with about a year and a half ago. So BESS Pluses will actually look at organizations whose on-site energy costs are about 100,000. So there's two tiers: 200,000 if it's just a pure BESS. If it's a BESS Plus, we can look at facilities as low as 100,000.
And I suppose the rollout is, a lot of people are going to be looking at battery technology with less than that. Going back to Michael, if you come off mute for a second, because I know you've been looking at this. Do you think that sort of small-scale battery rollout is going to be a viable technology? I mean, a lot of people would say it is at the moment.
I think it kind of depends on sort of what the market structures are. That I think I'd kind of agree with Brian that at the moment that it makes more sense to do it at sort of larger sites, and if you are going to do it at smaller sites, you want to be able to aggregate a large number of small sites together to be able to make a difference in things like the sort of balancing services market, for example.
So just on that, if you're looking at balancing services, I suppose the DNOs will want vast numbers of people to have batteries so that they can load shift and peak shift and use power from batteries rather than generating it and distributing it.
Well, I think that the DNOs are interested in flexibility of all sorts going onto the distribution network. So one part of that story is batteries. Another part of that story is demand side response. So that could be things like varying EV charging rates, or sort of turning things on and off, like sort of immersion heaters and things like that when we're looking at domestic users. But I guess that the important thing there is that there's a degree of coordination between those flexibility efforts, as that there are some ways of modeling the impact of storage where that if it's completely uncontrolled, that you could make things worse. So that's usually the sort of thought experiments of imagine rooftop solar systems that charge up sort of a storage device through the morning, and then as they hit midday peak output, then dump all of their output onto the distribution network when no one wants it, because theoretically outside of COVID we're all out of our homes and at the office. So that I think that there is a requirement for sort of smart control if we're going to go into a sort of small storage space at the moment.
So going back to you, Brian, I believe storage is going to be a major component of the network going forward.
As do I, and it's already going on. Now these grid scale deployments at the end of substations are popping up all over the country. Hey, I just need to clarify one thing in terms of those thresholds. Those thresholds are set by energy optimization in terms of a business case, in terms of when they go to do these projects. There's a lot of drag in terms of legals and accounting, et cetera, et cetera. So those thresholds, I say, they're set very consciously from a business point of view, but they are not a threshold from a technical or financial point of view where self-deployment can work all, if you're burning 10,000 pounds a year worth of power and you're willing to do this work yourself, you can make the economics stack up. It's just energy optimization has chosen that to try and optimize the number of projects that they're building and not be distracted with a bunch of small ones. So that's their choice, not an industry standard. So please, if to each of the listeners, your energy managers, please don't be put off by those thresholds. That's just a business decision that energy optimization is taking. Go do your own due diligence. You can probably make this stuff stack up.
Yeah, because I suppose before too long, we're going to be looking at domestic battery systems that make sense. Just one final question before we go on to Alexandra, because you talked about the greenness of the batteries. Float batteries have always been talked about, and different types of battery technology coming down. How close are we to a greener alternative than lithium?
Very close. There's multiple technologies out there that actually do work. They are green, but either there's a cost issue or a production issue of some sort that's keeping them at the moment, from wider deployment. But if one does a bit of homework, and Thunderset Energy is a great resource to go back and find the different chemistries that are out there. I think in the next 5 years, we will see a meaningful shift to multiple other battery chemistries.
Yeah, I went to the Oxford Institute who were doing a lot on this, and it is quite interesting, but the chemistries are quite complicated.
Well, curiously, there's a group out in California called Natron, who are doing a sodium ion battery that they say has a greater density than lithium ion, and it's totally inert from a flammability point of view. You do have a few problems with certain lithium ion chemistries where they tend to like to spontaneously combust. By the way, none of the ones that we're deploying use those chemistries, so please don't worry. But there's a sodium ion battery that could be, I'll call it the next big thing, or at least one of the next big things.
Excellent. So we're now moving on to Alexandra Hammond. Alexandra, I was really glad that you could come on to this, because a lot of our people do have the problem of saying, right, okay, I do want to come up with the technology. I want to work out how to do the framework. I've got to get it through my board. I've got to work out that I'm doing it in an economic and sustainable way. And that is a skill set that is quite specific. So do you want to run through your solution?
Sure. Thank you, Rupert. I'm conscious of time. You'll be happy to hear I really have one slide, which we can move on to. So my name's Alex, and I lead the sustainability team at ETL. We were previously known as Essentia, so some people know us as that. ETL stands for Essentia Trading Limited. We are a sustainability consultancy, essentially. We're owned by Guy's and St. Thomas's. And because of that relationship with the NHS Trust, we are able to establish procurement frameworks for, specifically for the public sector, but also used by the private sector to allow for due diligence and speed to market. We have 3 frameworks up and running at the moment, which some people may be familiar with. Patrick was on earlier, Patrick Doyle, who's from Bouygues, who's on our battery framework. We've also got Ian France from PowerStar, also on our battery framework. We've got an LED lighting framework and an energy performance contracting framework, which we're probably most well known for. Those frameworks are all continuing. They all have a couple of years left to run. However, for those working in the public sector, you'd have to be living under a rock not to know that there's a £1 billion grant fund currently on offer for the public sector to decarbonize their heat. It's a really important nuance that it's a focus on heat. So it's not just for energy efficiency. It really does cover heat as a priority, but can also incorporate energy efficiency projects. It can incorporate some of the wider enabling decarbonization technologies like batteries, like metering, BMS upgrades, et cetera. And when this was announced, I was very conscious that there's just no, people were going to get this money and have absolutely no idea or way to procure it, because it's, a lot of the focus of this fund is on heat pump technology, which is fantastic, but relatively a young market in the UK, and we wanted to make sure we had a really robust way of giving people a chance to use the money that they're given by BEIS and Salix through this fund. But also, this framework will be around for 4 years, so it's about future-proofing our journey to net zero across the UK. The framework is currently open for bids until the 4th of December. So if you are interested, I can send you details if you want to get onto the framework. There are 4 lots within the framework. So there's a kind of what we're calling all-encompassing or integrated technology lot. This is a lot like an energy performance contract that we may have seen in previous years. So that's that first one, the all-encompassing technologies. It really allows you to buy a range of technologies all in one go, and it's designed to be a streamlined process. It doesn't come with the traditional maximum capital cost and energy saving guarantee that you get in a energy performance contract, but that does enable it to be a bit more nimble and more dynamic, and move faster, because the fund criteria is pretty crazy. By crazy, I mean exciting. It's the money is to be spent ideally by the 31st of March 2021, and with exception 30th of September 2021. So we need to move quickly. This framework will be available from January. We are going to move very quickly through December to make sure that we get it all up and running and ready to go. But it'll allow people to buy a range of different technologies. If you're just after a heat pump, you can use lot 2, the heating and renewables lot. Really straightforward, ready-made contracts, and a robust process of vetting the supply chain so that there's a really clear and reliable way to go forward with it. So I will, I guess one thing I will say on this is at ETL, we are a little bit different in the way that we approach frameworks. We are a sustainability team, and we, alongside our frameworks, as part of our framework services, we provide sustainability advice and services. We have a lot of expertise within the team. So it's not just a transaction with us. We really try to make sure that the solution is tailored to the client and their requirements, and we work with the supplier and the client to make sure that relationship runs smoothly. The contracts are signed expediently, et cetera. So we really do try to add that value in. I won't add too much more to that because I appreciate that we are out of time, but I just hope it's of use, and will be, if that, my details are right there, sustainability@etl.co.uk, or just alexandra.hammond@etl.co.uk. Please let me know if you're keen to know more, and yeah, I really hope that it's a useful tool for the future.
So we've got a few minutes more. So I'll come back to you, Alexandra. The obviously putting, for energy managers going in front of the board, what would be your top tips for sort of how you present these and how you would then sort of present the framework, make sure that whatever you can do can go through a framework process?
Well, I think, we are seeing an acceleration of targets from the 2050 target to hit net zero. Almost every public sector organization, which is our core business, but and private sector organization wants to be to deliver that sooner. And so we're seeing is many boards declaring a climate emergency or acknowledging the need to move to net zero. And I think it's really important that we lean on that commitment and say, this is really what, in order to deliver that, it's a nice idea, it's a nice thing to state publicly, but in order to deliver it, that's going to require some really some major rethinking about the way that we operate our estates and build new estates as well. So I think it's being very clear about the decarbonizing journey, and also, where there's a fund and the money is essentially a grant, it's relatively straightforward to make that case to a board. Where there's an investment to be made, there's some, it's a little bit more of a tricky conversation. But I think it's about being leading. There's a really good report that the Carbon Trust put together on heat pumps and making the business case for heat pumps by using flexible tariffs, so electricity tariffs, the time of use. And I think it's really helpful because a lot of people think, if I put a heat pump in, my electricity bill is going to go up. And how do I manage that? And how do I manage not just the capital cost, but the ongoing revenue cost of that. So there's some really good solutions in that report that was published, I think, earlier this year. It's relatively recent. It's about a London case study, but it's relevant anywhere really. So I'd really say, lean back on the corporate commitments people are making and saying this really is what's going to be needed to be done to deliver it. And the framework itself, it's a really pretty easy case to make. It's fully compliant, ODU compliant. It's got a robust process sitting within it to vet suppliers, et cetera. And it's free. It's free to access. So there's not really a business case to be made about using the framework. It's something that we made available to the public sector.
Excellent. So. So that's what I would like is sort of wrapping up, because we've got another 5 minutes, is just taking out if there was one thing you would want to see in the next 5 years, that if you could wave the proverbial magic wand and you had your wish in the sector you're working in, what would that be? So I'll start off with Michael, because you're obviously quick off the mark.
Thanks, Rupert. I think for me that I'd like to see a large-scale trial be a success in the HGV segment, because from a decarbonisation perspective, that I think that's going to be a really challenging part of the economy to decarbonise.
Well, wasn't there an HGV that was running on batteries? Massive share price. Yeah. So I'd like to see a successful large-scale trial that is not a Nikola-style trial where the vehicle is just sort of rolled down a hill. And I think outside of my segment, I think I'd like to see a credible plan for what we're going to do about heat. As I agree with you that that's absolutely the elephant in the room. Yeah, I mean, we should have looked at heat, but that'll be another session. Brian, what would you like to see?
I would hope to see a pervasive rollout of battery energy storage and associated technologies across the UK, mainly because they're an enabler for a much greener grid. You can't have a green grid without the batteries acting as reservoirs and supplying electricity when it's needed, both through onshore wind, tidal, which is certainly the UK is a prime spot for tidal, although it has its own challenges. And although the sun's come out here, despite its climate, the UK is remarkably suitable for large-scale deployment of additional solar. So I'd like to see a journey to net zero, utilizing the EOS way if you can save money on the way. I think that's wonderful, and I think immersion cooling will actually supplant the data center topology over the next 10 years, because both the green case and the business case are so compelling.
Yeah, just on the energy cost of IT, computing is now far exceeding any other technology. But it's funny how the IT people in any company do not see it as their role of looking at reducing the carbon cost.
They're actually pretty focused on that, and again, it's as much a cost-saving things as a save the planet side of things. But when I reference that one site in just one building in East London, their annual bill for 7 floors of compute is £28 million a year. So it is a remarkable. There is, it was actually referred to briefly in the first session, the big question, COVID inspired, of what I call commute versus compute. So which one really is more energy intensive when you do a total sum of the amount of energy used to do your work, either from home or your normal commute to work, and all the associated on costs associated with that? I don't know what the answer is, but it'd be a fascinating study.
Alexandra.
I'd like to see our big energy users, manufacturing, public sector, estate, et cetera, reduce their reliance on fossil fuels. I think there's a real commitment at a government level that we haven't seen previously to enable that to happen. I'd really like to see that commitment continue so that people can make investments with a forward-thinking approach and fundamentally change the way that we power our major industries.
Excellent. Well, thank you for the panel. Gosh, we've almost spot on time. I have had a rather irate text from Jason. Obviously, with EMEX next year, we did work out that the actual carbon footprint of EMEX last year was 212 tons, which we offset. Whole argument about offsetting for whether that it should be the last point or the first, but I think we probably saved more energy in the energy managers learning about new technologies than we used, hopefully. So can I thank our panelists, usual online clap. Can I say thank you? Thank you to all the organisers. And now I'm going to pass over to Scott, who's got a nice cup of tea in his hands, which I personally am now going to turn off my camera, and I will be obviously here, but I'm desperate for a cup of tea. So thanks very much to the panelists, and Scott, over to you.